students, chapter 7, alternating current. Yes, in previous lecture we have discussed about AC voltage applied to a resistor, then AC voltage applied to inductor. Now in this lecture we will see AC voltage applied to a capacitor, and then we will compare these three theories. Okay, see here. AC voltage applied to a capacitor. If it is capacitor, AC voltage is applied. Yes, see, whenever capacitor is connected with DC source, that is battery. Yes, for very short time current is flowing because battery will charge capacitor. Okay, so yes, during charging process current is flowing. When capacitor is fully charged, current in circuit becomes zero. Current in circuit becomes zero. Clear about this? Again, when capacitor is connected with battery, that is DC source, current is flowing for very short time until capacitor gets fully charged. When it is fully charged, current flowing in the circuit will become zero. Okay, yes, but when it is connected with AC source, yes, it is charged and uncharged, charge, discharge in interval of time. Okay, how it gets charged and discharge, that charge and discharge, that we will see in this topic. Okay, so yes, this AC voltage applied to a capacitor. Yes, we are assuming one intermediate situation where here AC voltage applied to a capacitor means it is called purely capacitive circuit. Okay, here capacitor having capacitance C is connected across AC voltage having V is equal, having potential difference V is equal to Vm sine omega t. Yes, it is fixed in three theories. V is equal to Vm sine omega t. Now let at time t charge on capacitor is Q. It is one intermediate situation during charging process, for example, during charging process. So yes, in this case, you have to apply Kirchhoff's law. Apply Kirchhoff's rule. What is Kirchhoff's rule? Yes, V is equal to, remember first theory, AC voltage applied to a resistor, V is equal to IR. Second theory, applied to inductor, V is equal to LdI upon dt. Third theory, applied to a capacitor, V is equal to, it is Q upon C. Simple. Yes, Q upon C. So therefore, Q is equal to, it is Vc. So yes, or you can write it is C, no problem. So it is C. What is V? V is equal to, it is Vn sine omega t. Here it is Q. Now you have to find equation of current. You have to find equation of current. So how to find equation of current flowing at time t? Okay, so current in circuit at time t. At time t, I is equal to dq upon t. So is equal to, it is d upon dt of Cvn sine omega. Any doubt? Okay. So yes, how to write this now? So therefore it is I is equal to C Vn, constant out of integration. What is differentiation of sine? Yes, it is cos omega t. And yes, it is omega t, you have to again differentiate. So you will get this omega. Clear about this? Then how to write this? Yes, I is equal to, it is omega c Vn cos omega t. Omega c Vn cos omega t. Any doubt? Okay. I can also write this equation as I is equal to, it is Vm 1 upon omega c cos omega t. Now why to write like this? Because we have to compare these two theories. Remember, first theory I is equal to Vm upon R. Second theory I is equal to Vm upon omega L. So here, yes, we have to make the same form, that is Vm upon 1 upon omega c cos omega t. So I can write this equation as I is equal to Im cos omega t. I is equal to Im cos omega t. So yes, this is the equation of current. I is equal to Im cos omega t. Where Im is equal to Vm upon 1 upon omega c, where Im is equal to Vm upon 1 upon omega c. Clear about this? Hello, clear about this? So yes, again, capacitor having capacitance C is connected with alternating voltage V is equal to Vm sin omega t. At time t, charge on capacitor is Q, so apply Kirchhoff's rule, V is equal to Q upon C, and Q as subject. We have to find current, then differentiate this equation, we get this I is equal to Im cos omega t, where Im is equal to Vm 1 upon omega c. Now remember, if you compare this theory with second theory, then you can easily write. Okay, yes, here is 1 upon omega c. 1 upon omega c is called 1 upon omega c is called capacitive reactance. Is called capacitive reactance. And it is denoted by Xc. Xc is equal to 1 upon omega c. So yes, here I can also write this equation as Im is equal to Vm upon Xc. Im is equal to Vm upon Xc. Clear? Any doubt? Okay, so yes, here it is. 1 upon omega c is called capacitive reactance. It is denoted by X is equal to 1 upon omega c. And yes, dimensions of 1 upon omega c, that is Xc, means capacitive reactance, is similar to dimensions of resistance. Okay, and therefore its unit is ohm. Clear about this? Yes or no? Yes. And again, this capacitive reactance controls current in purely capacitive circuit. Yes, in last lecture, in last theory, okay, same statement. Okay, in resistive circuit, resistor controls current. In inductive circuit, omega L, that is XL, controls current, inductive reactance. In this theory, 1 upon omega c, that is Xc, capacitive reactance, it controls current. Simple. Yes or no? Yes, it is. Okay. Yes, Xc is equal to, it is capacitive reactance. Xc is equal to 1 upon omega c, means it is 1 upon 2 pi fc, means this capacitive reactance is inversely proportional to frequency. So yes, this point you have to remember. Take it inversely. It is inversely proportional to frequency. Xc is inversely proportional to frequency and capacitance. Clear about this? Okay. So yes, first point, we have to obtain equation of current, then equation of maximum current, then what is 1 upon omega c, its comparison. Now it's time to draw graph of I and V versus T. And also, what is phase difference between them? See, yes, voltage V, AC voltage, here AC voltage V is equal to Vm sin omega t, and AC current in circuit, AC current, it is I is equal to Im sin omega t. It is I is equal to Im sin omega, sorry, it is I is equal to Im cos omega t. I is equal to, it is Im cos omega t. Clear about this? Okay, so yes, here this AC voltage, it is function of sine, and its phase is omega t. Here this AC current I is function of cos. So yes, obviously we have to convert them in the same function. So I can write this I as I is equal to, it is Im sin omega t plus pi by 2. Omega t plus pi by 2. Yes, I can write like this. Yes or no? Yes, I can write like this. I is equal to Im sin omega t plus pi by 2, because we know that. See, here it is. Okay, is sin omega t plus pi by 2. I can also write as sin pi by 2 plus omega t, and sin pi by 2 plus theta, it is cos theta, it is cos omega. It is cos omega t. Simple. So yes, I can write sin omega, this cos omega t is equal to sin omega t plus pi by 2. Now observe, see here. Now V is function of sine, I is also function of sine. V is function of sine, I is also function of sine. See, here it is. Okay, here it is. Now it is okay. Yes, now it is okay. Again, AC voltage, V is equal to Vm sin omega t. Current I is equal to Im cos omega t. I can write cos omega t as sin omega t plus pi by 2. How? Sin omega t plus pi by 2 is equal to sin pi by 2 plus omega t. Okay, and sin pi by 2 plus theta is cos theta. Clear about this? Yes. Now see, here it is. Voltage is function of sine. Current is also function of sine. Phase of voltage is omega t, and phase of current is omega t plus pi by 2. It is omega t only, and it is omega t plus pi by 2. Means phase of I is greater than phase of V. So here what is statement? Here statement is, okay, here current I leads voltage by phase pi by 2. By phase pi by 2. Here current I leads V by phase pi by 2. By phase pi by 2. Clear about this? So yes, you have to remember this point. Okay, leads means phase of I is ahead of voltage by phase pi by 2. So yes, it is difference between purely inductive circuit and purely capacitive circuit. In purely inductive circuit, current I lags behind voltage by phase pi by 2. Where here it is opposite condition. Clear about this? Now you have to draw graph. Yes, how to draw graph? See, here it is. It is omega t. Yes, it is 0. V is equal to Vm sin omega t in each and every theory. So yes, its graph is like this. It is graph of V. Okay, it is Vm. Yes, it is minus Vm. Yes. Okay, what is graph of I? To draw graph of I will consider this equation. That is I is equal to Im cos omega t. That is I is equal to Im cos omega t. Yes or no? Yes, it is. I is equal to Im cos omega t. And see how to draw its graph. Yes, as it is plus cos. I can draw its graph like this. Yes, I can draw its graph like this. So it is graph of, yes, it is graph of I. It is graph of I. This orange one is for V, and this blue one is for I. It is for I. Clear about this? So it is graph of V and I versus omega t. Clear about this? Points? you have to cover, that is, draw this figure. AC voltage, obtain equation of current, then you have to write about this 1 upon omega c, that is capacitive reactance. Then yes, this phase difference, you have to draw this graph, and now it's time for power. Now see, here it is, AC voltage, yes, again AC voltage, V is equal to Vm sin omega t. AC current, I is equal to Im cos omega t. Yes or no? Yes, it is. So what is instantaneous power? Instantaneous power. Why we use instantaneous? Because we know that power, instantaneous power, P is equal to, it is Vi. Vm sin omega t, Im sin omega t. If you take time t is equal to 0, then it is voltage at time t is equal to 0, it is current at time t is equal to 0, and it is power at time t is equal to 0. At that instant, if you change value of t is equal to 2, then voltage at t is equal to 2, current at t is equal to 2, power at t is equal to 2. Yes or no? Yes, it is. So we need instantaneous power. Instantaneous power, P is equal to Vi is equal to Vm sin omega t, Im cos omega t is equal to Vm Im divided by 2 sin omega t cos omega t is equal to Vm Im divided by 2 sin 2 omega t. Yes, it is instantaneous power. It is instantaneous power. Now, how to find average power? So yes, average power. How to find average power? Yes, I can also write this average power here. Okay, how to find average power? Average power. Yes, average power P is equal to, here it is, average of Vm Im divided by 2 sin 2 omega t. Yes, we know sin, average of average power over a period, average over a period. And yes, we know that average of sine over a period is 0, so here average power is 0. So again in purely capacitive circuit, average power is 0 in purely capacitive circuit. Average power is 0. Average power is 0. So yes, these points you have to cover when you are asked the AC voltage across a capacitor. Okay? Now we will see one comparison between these two cases, between these three cases. Purely resistive, purely inductive, purely capacitive. What is same in this three theory? Yes, AC voltage. That AC voltage in these three cases is AC voltage. V is equal to Vm sin omega t. V is equal to Vm sin omega t in this each and every case. And what is equation of AC current? Yes, what is equation of AC current? AC current, I is equal to Im sin. How to write? So here it is. Omega t plus or minus del. Where what is del? Del is phase difference. Phase difference between I and V. Del is phase difference between I and V. Yes, what is phase difference that we know? What is phase difference that we know? Okay. Now, AC voltage V is equal to Vm sin omega t. In three cases same. AC current I is equal to Im sin omega t plus or minus, where what is Im? In this case, Im is equal to Vm upon I. In this case, Im is equal to Vm upon XL, or I can write Vm upon omega L. In this case, I can write Im is equal to Vm upon Xc, or I can write Vm upon 1 upon omega C. Yes, resistance, inductive reactance, capacitive reactance. Yes or no? Yes, it is. Yes, it is. So yes, you have to remember these three cases. In this case, I and V, they are in same phase. I and V have same phase. They have same phase. Same phase means phase difference between V and I, that is delta is equal to 0. That is delta is equal to 0. Clear about this? Okay. In purely inductive circuit, yes, in purely inductive circuit, okay, here I lags behind V by phase pi by 2, by phase pi by 2. Yes or no? By phase pi by 2. Yes, it is. Yes, it is. While in this case, yes, I leads V by phase pi by 2. By phase pi by 2. So here, what is equation of current? This equation of current is Im sin omega t, because you have to put there is equal to 0. In this case, what is I? I is equal to Im sin omega t minus pi by 2, means del is equal to minus pi by 2, means del is equal to minus pi by 2. And here it is, yes, here I will write only plus. Here I will write only plus. Okay, here it is I is equal to, it is Im sin omega t plus pi by 2. Omega t plus pi by 2. So it is difference. It is difference first of current, then for phase difference, then for equation of current. And yes, you know what is difference between their graph. Yes, boy, you know what is difference between their graph. Okay, average power over a period. Average power over a period. In this case, average power over a period is equal to, it is I square RMS I. In this case, average power is equal to 0. In this case also, average power is 0. Clear about this? So it is comparison between purely resistive circuit, purely inductive circuit, and purely capacitive circuit. Clear about this? Okay, so yes, these equations you have to remember. See, these equations you have to remember to calculate questions. XL is equal to omega L, while X is equal to 1 upon omega C. So inductive reactance is directly proportional to frequency, but capacitive reactance is inversely proportional to frequency. So such relations you have to remember. Clear about this? So yes, we have completed three theory: AC voltage applied to a resistor, AC voltage applied to inductor, AC voltage applied to capacitor, their equations, full theory, and then comparison between them. And yes, for today, this is it.